Hello everyone, I'm Rahul, reporting from the Fun Robotics Network, and here with me is Team 21380 Beyond Robotics, who have had a very amazing season with their super fast and simple intake system, their transfer system that's 100% consistent, their fast outtake slides, their 5 specimen autonomous. There's so much to learn about this robot on Behind the Box. Alright, why don't you guys start off by talking a little about your game strategy and general design this season?
Of course, our game strategy this year basically comes from us analyzing the game season. We analyzed the game season and came to the conclusion that cycling samples will result in the highest amount of teleop points, whilst having a specimen autonomous would result in the highest amount of autonomous points possible. Our design strategy revolves around basically the same idea of having a very generalist robot design. Basically, our robot can constantly adapt to situations. For example, if our alliance partner wishes to cycle samples, we will cycle specimens and vice versa.
Okay, so now thank you for that insightful game strategy. Now let's just jump straight into your drivetrain. I see you've got this full pocketed aluminum drivetrain. Talk to me about what ideas went into this pocketing, what motors you run for your drivetrain, because you're very fast. You have a very fast drivetrain.
So our drivetrain is made up of 4 of these side plates. We have them custom designed and sent to a certain mentor to help us get these pocketed and printed. We made it pocketed just so our robot would be light and just faster in general. We have six 435 RPM motors underneath the robot, which improves our speed significantly. We also have mechanism wheels with grip on it to allow extreme acceleration and power.
That's very nice. I have a couple follow-up questions. Have you seen the grip force to be a noticeable difference between the old 96mm Go Builder mechanism wheels in terms of acceleration and such?
Yes. Our new mechanism wheels allows us to increase speed extremely fast and allows us to not like swerve around and drift or any extra movements.
Nice. Now, one thing that caught my eye here is I see you guys have some gears behind the drivetrain pulleys. Is that plans for a future power takeoff or some sort? Or are they just there for spacers or some sort?
Our robot was supposed to have a hang, so we were going to use the power takeoff to allow us to use all 6 of our motors underneath for our hang as well.
Mm-hmm. And is that like a future design thing that you're going to implement?
Yeah, that is one of our future designs that we have.
Nice. No, I can't wait to see that in action. Now, let's go straight into your intake system. Show me how it works, how the virtual 4-bar works, and maybe if you can demonstrate it with a sample or some sort of thing like that.
Yeah, so our intake bucket is connected to a virtual 4-bar and pivot mechanism. So it allows us to have 4 different positions and no dead spots in the field. Our first position that we have is intaking from the ground, allowing us to intake any sample no matter what position it is in. That is due to the tubing, 2-directional tubing that we have, allowing one side to go in first and then the other side to go in. This allows no jams or problems during the game. Our second position is our spit out position. It looks like this. If we get any wrong color samples or extra samples, we are able to spit it back out into the submersible. Our third position is our shuffle. It's a little lower than our spit out position. It allows us to shuffle samples in from the top, allowing us to grab from both the bottom and the top. This makes our robot extremely unique and special, different from any other robot. Our final position is our resting position. This position allows the intake to have a flawless transfer to our output position.
Mm-hmm. Wow, no, I'm gonna just jump straight into that. So first of all, with your intake rollers, it looks like you have the Axon Mini geared on some ratio. What were your design considerations on that to use a servo and not a motor? And how did you decide on the ratio to use on the servo to put the tubing on?
So our Axon Mini servo, we use this just because we realized that our tubing intake speed wasn't enough. And that is also the same case for our gear up over here, our 40 tooth to our 20 tooth. We used both of these to increase our speed to 100%. We also have a servo power module back here to increase our speed by another 20%. So in total, it increased our intake speed by 120, allowing us to pick up easier from the top.
Nice. No, on the topic of the servo power module, have you had any issues with that? I know a lot of teams have had some burnouts, or are you planning to switch to the new servo hub release, or any ideas on that?
So we did have one issue we saw. It was like 2 days before this tournament actually. When our backup claw driver was testing our claw, he slammed into it, creating like some sort of burnout in the power servo module. Mm-hmm. Luckily we had a backup and we just replaced it.
Nice,
That's
nice.
it.
Okay, that's interesting. Now, again, on your intake, I think it was really cool how you guys had all these different intake positions, one down, one up. How effective is your up position compared to your down position? Because I think the ability to do both is really crucial.
So our up position is not as like efficient and like capable as our down position, but it does allow us to like pick up these samples that are stuck against the wall or in large groups that usually the bottom one can't do. So it's really helpful in very tough situations.
Nice, nice. And I see you guys have their transfer system. Can you show me how that would work and how in general that idea the motion works?
Yeah,
that you
so
fit in?
our transfer is used by our active linkage 200/300 ratio and our SAR 220 Mitsumi slides. So these two connected to our 4-bar and pivot intake. So the 4-bar and the pivot allow the fourth position, resting position, just to stay here. We just extend and retract using the linkage, and it just perfectly stays here, allowing us to grab.
Yeah, I think that transfer is really cool and really unique. Now, again, on the topic of your extendo slides, it seems you're using a linkage with some Gobilda beams. What was your decision behind using the linkage and those beams in particular rather than string or belt for the extendo?
We wanted our robot to be extremely simple and fast, so we added these linkage just because it was really easy and less complicated than all the strings that we'd have to do if we connected our horizontal to our vertical. So that was like our main idea for that.
Nice, nice. That's really cool. Now, on the topic going into after the transfer into your outtake system. So, describe what degrees of freedom you have here on your outtake system and how you utilize those in the game.
Our outtake consists of 3 parts, and that includes the claw, which is custom designed so I could grab samples very easily. It is controlled by an Axon mini servo, which controls the actual closing and opening of the claw. In addition, our claw can pivot, allowing us to score specimens. All we have to do is turn the entire claw over on this side, grab the specimens over here, and then flip it again so that we can score from top to bottom. Our claw can also pivot thanks to a Gobilda servo. The Gobilda servo is fast, allowing our claw to pivot pretty quickly.
Nice. Now, so I think that specimen motion is really key for you guys in that autonomous period. So what design decisions went behind that? I see you guys pick it up on the wall and you slam it down onto the specimen bar really quickly, turning it in the middle. How did you guys come across that? Did it come through multiple iterations? Do you have any suggestions for other teams looking to implement something similar?
It simply came from analyzing the game. If you can see from our poster, we went through multiple design phases and iterations throughout the meets. Initially, we obviously didn't come up with this transfer system. We came up with it, I think, during our meet 3. Initially, we used a single pivot arm instead, which after many testing and playing during meet 2, we came to the conclusion that it just wasn't fast enough. So we obviously switched, and thus it came to we decided to use this much better system. So I'd suggest basically go through testing. Don't be afraid to make mistakes when designing and analyze the game.
Nice, nice. Now let's go straight into your outtake slides. So your outtake slides seem like some Mitsumis driven by a string. What is your experience with these Mitsumis, and would you recommend them to other teams?
The Mitsumis, they're pretty fast. They can come in all sorts of lengths. For our vertical slide, we use a 240mm Mitsumi SAR because we wanted our slide to be able to reach the high basket so that we can score samples.
And what ratio, by chance, you know that you run on the vertical lid? Because it's very fast and speedy.
So we have a gear up ratio of 60 to 48. That allows our slide to move very fast. So that cuts down a lot of time when it comes to sample cycling.
By any chance, you know the motor ratio before that 60 to 48 ratio?
The motor that we used are also 435 RPM.
435 is nice, nice. Now, I think that's great. I think your transfer system and your intake are really seamlessly connected. Let's go into your software side of this, because your autonomous is just so consistent and so impressive. What are some, why don't you go into what sensors you guys use, how you guys localize, and things like that?
All right, well, first off, I guess one of the most obvious parts of our autonomous is basically that we don't move our slide at all, which makes it a lot easier, right? So our arm is perfect length to score specimens on without moving the slide. It just goes down. basically our robot can just be touching the submersible wall and it'll be able to score, right? So because of that, we use a touch sensor to score instead of like using localization, because it's just basically a guaranteed method of scoring. And then the localization we use is backup, and then it's basically a backup if in case that our touch sensor doesn't touch.
Okay.
But yeah, and about our localization, so under the robot, we have two 4-bar Go Builda odometry clouds. To help with that. All right, so see here, we have this is our perpendicular, this is our parallel, and then we're running 2-wheel with IMU, but our IMU is a pinpoint odometry.
Nice.
So
how's your experience been with pinpoint? I know a lot of teams have switched to that this year.
I find it pretty nice because basically instead of having to go with like all the 3 dead wheel localization, pinpoint is pretty easy. All you have to do is pretty much just set up the wheel offsets, and then you're basically done for it.
Nice. Yeah, I think that touch sensor and all that the touch sensor is really smart to do with your transfer. Do you guys use that touch sensor in teleup as well, or is it only for the autonomous period?
It's only for the autonomous period, since basically like during the teleup period, you can basically almost always tell if your robot's hitting the sub because you're literally running in there. But we do use some of the other touch sensors in teleup. So here we have our horizontal slide touch sensor. This serves as a slide limit since we're running these servos on continuous mode. Since basically instead of having to like think too hard about the servo positions, we just let it run, and then this is our position, right? So we use this to give driver feedback. So it gives a vibration to our claw and outtake operator, and then that gives the signal to basically grab when we're doing samples. And then we also have another, this isn't really used with our teleup, but it helps with our vertical slides. We have a touch sensor in here for resetting our encoders to the 0 position and basically as a slide limiter.
Nice.
And we also have a color sensor over here, which was originally used to power this LED to give our drivers like a sense of what color the sample they currently had was. But then we realized the drivers are usually focusing on the intake. They're not going to look at the light. So we're maybe considering replacing that with a vibration, or maybe finding a better spot to put the LED on.
Nice. No, I think that's really cool how you use all these different touch sensors to help automate it. So since you've got so many different cool mechanisms on your robot, is most of your transfer is it that mostly automated in the teleup section through some sort of state machine? Why don't you guys talk to me about that? Or does the driver do that themselves?
We do a lot of state machines. So state machines are in our auto for just detecting all the touch sensor work and all the sensor work, but also in our teleup, we use it to make an autocomplete mode, which I believe boosted our sample cycles from 12 to 17, and then we're working on that, and it's getting up to around 19 now. And then basically it just, instead of having to do 3 buttons, we use the slide up and then the outtake out, and then basically our driver can use another autocomplete state machine to basically just open and then back down to here, and then basically back down to the original position. And there's another one just for here to basically help with our specimen mode, where we basically just grab, it slides up slightly so that our sample doesn't hit against our intake, and then it just it slides back out and then drops, and then it slides back down again. And then this would ready our claw to pick up from the specimen wall.
Nice. Wow, I think that's really impressive how you've automated this much. So now, obviously, this is Interleague Meet 4 for you guys, and you guys are doing really well today, so I'm sure you guys will advance to SoCal Regionals. What are your plans for future improvements going to SoCal Regionals and potentially even higher competitions like Worlds or MTI or things like that?
Okay, so, well, first off, I guess we'd probably want to improve this color sensor to maybe give more driver feedback, and then also improve some autos, so maybe we could see a higher sample auto and a higher specimen auto.
So do you guys plan on adding some sort of vision to get from the submersible in autonomous to get that 6th specimen or 5th sample or something like that?
We're probably planning on using our limelights. So we've been testing with limelight, but we haven't added it on since we're gonna probably, if we make it to regionals, we'll be preparing to use limelight for computer vision.
Nice. Is there anything else you guys like to add?
I want to add that we want also to add a hang, because we don't really have anything that's for endgame. We just continue off what we left in like teleup. So yeah, we consider about getting a hang.
Would you guys plan to get a level 2 or some sort of level 3 hang? And how would you guys, what's your guys' goal to achieve that?
We'll probably use a level 2 hang for sample cycling, but a level 3 for specimen cycling. If you look here, we still have some of the remnants from our previous design with our hang. So originally we were an arm bot, but so take a look over here. These are zip ties to secure our slides to our main chassis, because originally we have this on a pivot so that we could operate a hang.
Wow, okay, that's really interesting. There's so many cool parts to this robot. Thank you so much, Beyond Robotics, for this interview. And reporting from the Fun Robotics, I'm Rahul. Catch you next time on Behind the Bot.